Hi, Mr. Leonard here to review how to draw atoms and ions. Now remember, before you get started, there's a few things that you need to know to draw any atom, and that's the number of protons, electrons, and neutrons. You already know how to find these things, and that's going to come from the information off the periodic table for each element. This number up here is the atomic number, which tells you the number of protons, which in this case is 9, or electrons, which is also 9. To find the number of neutrons, you need to take the atomic weight minus the atomic number. In this case, 19 minus 9 is 10, so I'm going to plug a 10 in there for the number of neutrons. Your first example passed the one that we did in our last podcast was fluorine, so that's what we're going to draw. Now remember, the number of protons and neutrons always go in the nucleus. So I'm going to write 9p for 9 protons and 10n for 10 neutrons. Now since we have 9 electrons, we need to disperse those on our energy levels. Remember, the first energy level can hold a maximum of 2, the second can hold a maximum of 8, and the third for our class can also hold a maximum of 8. Since we have 9 electrons, we can't fit those all on the first energy level. We can only fit 2 of those. That leaves us with 7 remaining. So we are going to spread those out on the second ring. Remember, I like to draw them in pairs because it makes them easier to count. And in this case, we have our total of 9 electrons. 1, 2 on the first energy level, 3, 4, 5, 6, 7, 8, 9. So our regular fluorine atom is done. The ion for fluorine is labeled as F negative. You'll see why in a moment. When you're drawing the ions, the nucleus is going to look exactly as it does for the regular atom. Remember, the only thing that's changing is the number of electrons with ions. Okay, so I have the first 2 electrons on our first energy level. Now, all ions are stable, and what that means is that their outer energy level is filled. We have 2 options for fluorine. We can get rid of 7 electrons, which would be really hard to do, or we could add 1 electron. It'd be much easier to do that. So let's add 1 electron. So instead of having 7 on the outer energy level, we end up having 8. Excuse me. So we have 8 now. This is the extra electron on our outer energy level. And if you look up here, the second energy level can hold a maximum of 8. So fluorine is now stable. It's happy. And that's why it does this. The reason why it has a negative sign up here is because it has 1 extra electron, and those have negative charges. So we were able to complete this, and this is what your drawing should look like. The next example was magnesium. We're going to do the same thing that we just did. Based upon what we already know, magnesium would have 12 protons, 12 electrons, and it would have 12 neutrons. 24 minus 12 is 12. Okay, let's get started. Protons and neutrons, remember, always go in the nucleus, so we're going to have a 12p and a 12n. Okay, now it's time to put our electrons on. We have 2 electrons on the first energy level. That leaves us with 10 remaining. 2, 3, 4, 5, 6, 7, 8. I still have 2 left, so I need to go to a third ring, which I'm just barely going to make it on this screen. Sorry for these horrible circles. And I'll just put them right here. They can really go anywhere on this ring. So there's our regular magnesium atom. Now to draw the ion, the nucleus is the same. 12p, and 12n. The only difference is that it's stable. Actually, if we take a look over here first. So to make this stable, excuse me, to make this stable, it would be easier to get rid of 2 electrons rather than add 6, because remember the third energy level can hold a maximum of 8. So since it's easier to get rid of 2, that's exactly what we're going to do. I'll draw my second ring. I will add in my 8 electrons. So now this is stable. The outer ring is filled. The second energy level is filled. All of your ions, when you draw them, the outer energy level should be filled. The reason why it's +2 is because we have 2 more protons than we do electrons. Right now, on this ion, we have a total of 10 electrons. So, versus our 12 protons. So we have a +2 charge. All right. So there's the second example on that page. And the last example is sulfur. We go through our normal steps. As we see here, 16 protons, 16 electrons, and 32 minus 16 is 16. Okay? To draw our sulfur, we start with our nucleus. We're going to have 16p, 16n. The first ring will have 2. That leaves us with 14 remaining electrons. We can fit 8 of those on here. So right now we have 10 total electrons. That leaves us with 6 remaining, so we need to go to a third ring. 1, 2, 3, 4, 5, 6, and that's it. Now, sulfur in its normal state is not stable. Remember, the outer ring needs to have its energy level filled. The easiest way to do that is to add 2 electrons. So our example over here, we're going to do just that. So we're going to do our exact same drawing, except it'll have 2 more electrons on that third ring. Okay, we are almost done. So I've drawn 10 electrons, 1 more ring to go. And I'm just drawing these in pairs, remember, just to make it easy to count. And there we have it. So we've drawn our sulfur ion as well, which has its third energy level filled, which means it's stable, which means that it's happy. So again, all of your ions are going to have the outer energy level filled. What I would like you to do with a partner in class is double check the backside of your page with someone that you did not already work with and make sure that your drawings are identical. If you have any questions about how to draw ions, you can watch this video again at any point.